Okay, so warming's a sure bet. As I said before, because warming's a sure bet, it gives us more confidence in other things. Okay? What's one big thing? Snowpack is going to be less. You know, unless we get a huge increase in snow, which you'll see in a minute we're not going to get. Because it's warmer, it's going to melt sooner. It's going to melt more. It's going to sublimate, meaning the snow will turn straight from frozen white stuff to water vapor in the atmosphere. These things will all contribute to less stream flow. Turns out, again, this has already happened. It's not something that is a what if. What you can see here is a global map of the, northern hemisphere map. Here's the North Pole, here's North America, here's Eurasia here. All the brown colors are where we're seeing a decrease in spring snowpack. Not winter, it's spring, where the temperatures can melt the snow earlier and earlier and earlier. Okay, all the places where there's brown, we're seeing earlier melting and less snowpack in spring. The places where we see in blue, we're not seeing that. A lot more brown than blue on this map. Okay, bring it home to the Colorado headwaters, our river. Here's there won't only be melting earlier, but more precipitation will fall as rain than as snow. Right? This is a plot going back as far as we have data for the Colorado Rockies, showing the ratio of snow water equivalent, meaning snow converted into equivalent units of rainfall, to rain. And so we went from a snow-dominated system back in the 50s and 60s to what we're getting now, which is a more rain-dominated system. And you see there's a lot of variability from year to year, and that's another reason we don't trust any one year to tell you what's going on with this. But looking over 50 years, it's pretty clear. And anyone who skis in the room knows that once you get rain on snow, that even makes the situation worse. It melts things faster. So things are not looking good for snow. Moreover, all the models suggest, all but like one, that we should get less late winter precipitation, meaning late season snow in the mountains, rain down here. This is talking March and April. Right? We get a lot of our Colorado River water in these months. The models are suggesting we should see less of this. And that's what's happening. Because what's happening in both hemispheres as the plant warms is the jet streams are moving poleward. And as those jet streams move poleward, so do the storm tracks. That's why we're getting more snow and rainfall north of here progressively over the decades. Right? And this trend should continue. And again, we have a lot of confidence in because the models and the observations match. Right? So here's what the models, averaged over multiple models, again, not taking an extreme worst case, looks. For winter precipitation and spring. Winter is December, January, February. Spring is March, April, May. And you can see in our part of the world, unfortunately in the whole river basin in spring, projections are for less precipitation. Oh, okay. The areas of brown mean less, the blues mean more. And wherever there's stippling, means the models agree. Or give us statistically significant confidence in the assertion that we're going to see less spring precipitation in our part of the world. And it's going to, if it comes to snow, it's going to melt faster. And that's not good for river flow. Okay? And we're pretty darn sure, because of the warming then, because of what's happening, that we're going to get less river flow, less stream flow. Stream flow is the fancy word for it. Okay? So what we're seeing in Lake Powell, this is right at the start of this big drop in rivers, in the big storage units and big reservoirs. What we're seeing here is not a big surprise. It's what was predicted. Because it's actually happening, it gives us a lot of confidence that it's going to continue. Here's the actual time series of water in Lake Powell in blue and Lake Mead in red. You can remember during the Great Depression, that's when we started building all these big dams. That's when we built Hoover Dam. That's when we started filling up Lake Mead. And we filled up by the early 40s. And then there were some substantial droughts, and we recovered in the 1950s and the 60s. We recovered primarily because there was very little water use going on in those years. The big cities in Colorado were not draining this river and using the full allocation of water. The big agricultural centers were not using that. So this lake had recovered. Then we built Lake Powell, one part of our canyons, and it filled up too. And then right around the beginning of this century, they both plummeted. They plummeted because that's when we started the drought. We're still in now. Drought's come and gone. In certain seasons, we've been pretty much continuous drought since the beginning of this century. And you can see both plummet, and you can see Lake Powell is starting to refill as the upper basin has said we're going to fill our reservoir. And our reservoir up to the lower basin, Lake Mead, continues to drop. Right now we're 39% full for Mead. Haven't been that low since we were filling it back in 1937. And we're up to 59% for Lake Powell. So average them, and they're less than half full.